Hi there, welcome to chapter 13 from our specialist maths book. So that's what we'll be working through now, which is probably a bit better for you. Hang on, I'll just get a pen. So you can use your actual textbook or you can go online. If you look on Canvas, you'll see that the work completion is on there for chapters 13 and 14. There's some other resources there which we'll just come to as we need. So today is 13A, reviewing trigonometry. So you've done this before, but probably not since year 9. So it'll just be expected next year in your unit 3-4 that you know how to do this. So we'll just take a little while to go over it. So hopefully you all remember without too much grief the unit circle. So the unit circle is a circle that has a radius of 1 unit. The distance along here is cos theta and the distance up here is sine theta. So this coordinate here is cos theta, sine theta. So if this unit circle was twice as long, this would be 2 cos theta, 2 sine theta. If it was 3 times as long, it'd be 3 cos theta, 3 sine theta. And that's how we get our formulas for sine, cos and tan. So you hopefully remember from year 9 that the sine of theta is the opposite over the hypotenuse. So the opposite is this one here and the hypotenuse is here. So in this case it's over 1. If this was length 5, it'd be over 5. And then you should remember hopefully that cos theta is adjacent over hypotenuse and tan theta is opposite over adjacent. And this is course is when we've got a triangle. The angle here is theta. This is the hypotenuse. This is the opposite and this is adjacent. And adjacent just means next to. It's just not a word that we use that often. All right, so the way we remember that is we go sine opposite over hypotenuse. So cos adjacent hypotenuse, car, and tan opposite adjacent, toa. So, ka, toa. All right, so the other thing that we'll need to remember is that tan theta is sine theta over cos theta. And I'll send you a little meme about the tangerine, the sine-gerine and the cos-gerine. Okay, so let's do some questions. I'm going to choose some from the textbook. So 13A is on page 390. And I'm going to do question 1B. It looks like this. So the first thing I think we should always do is go through and label your opposite, your hypotenuse, and the adjacent. We won't bother with that because we don't know what it is, but we don't really care what it is. So we're just going to say, what have I got? I've got O and H, so we go up here. Sine is opposite over hypotenuse. So in this case, it'll be the sine of 5 equals x over 10. Then rearrange, x equals 10 times sine 5. So x equals, I worked that out before. No, I didn't. If you do 10 times sine 5, you'll get the answer. Do you want me to look it up? Hang on. This is just like real life. 13A, 1B. It is 0.87. So can you get your calculator and make sure you get that? This here, it must be in degrees because this is in degrees. So if your calculator is still in radians, you're not going to get this right. In fact, you're going to get all of them wrong. So go back now and change your radians to degrees. And the more you do, the more proficient you'll be. What else am I going to do? I think that one will do for now. I'll also do question 2, even though that's not on your, that is on your list. I just know that every year the kids find it difficult, so we'll just shortcut it and have a look at it together. If you find that on page 390, it says an equilateral triangle has altitudes of length 20. So I'm going to draw an equilateral triangle. The altitude, this one here, is 20. You need to find the length of one side, which would be this. So it seems we don't have enough information, but equilateral triangle, we know that that's 60 degrees. They're all 60 degrees. So if I redraw that over here, I've got 60, I've got 20, and we want to find the length of one of those sides. So again, I'm going to go opposite hypotenuse. It's a sine. What have we got? Sine 60 equals 20 over x. So x times sine 60 equals 20. Or we could say x is 20 over sine 60. And you might be able to go straight to this third step and miss that middle one out. And if you do 20 over sine 60, you get 40 root 3 on 3. So in this case, I think probably an exact answer wouldn't be needed, but we need to get in the habit of using exact answers all the time unless we're asked for a decimal answer. The other one I'm going to look at is question 5, page 391. Here we are, question 5. It's got a ramp, and this ramp is 6 meters long and 1 meter high. And question A says to us, find the magnitude of angle ABC. So magnitude just means size. So it's saying how big is angle ACB? So if we look at our diagram, A to C to B, we want this angle in here. So it's always that middle letter. So what do? It's a sine again. Oh, we should have mixed it up, shouldn't we? So sine of theta is 1 over 6. So that means theta is the inverse sine of 1 over 6. So again, make sure you're in degrees. Look in that trig menu and you'll find that that's 9.59 degrees. For part B, it says find the distance BC. So that's this one here. Look, I could use the angle I've found here, but if I've done that incorrectly, I'll use that answer incorrectly and then get the next one wrong. So in part B, I'll want to say distance BC. I'm just going to use a good old Pythagoras theorem. I'm going to say 6 squared equals, I'm going to call this x squared plus 1 squared, so 36. So x squared is 35. So x is just the square root of 35. We know it's going to be positive because it's a distance. Okay, so that's 13A, should be revision. You might find a few tricky ones on the way through. The full solutions are actually up on Canvas, so make sure you have a look at those. Otherwise, just let me know and I can go through some of the others. Good luck.